Drawing is very important because if you go to any hotel or a good guest house, what do you see behind the door of that hotel or a guest house? You find a fire exit plan. Now, do tell me, do you find it written? Take 500 steps right, take 200 steps left, take 50 steps back, you will find the nearest escape ladder? No. It shows you where you are, it shows you where the fire exit is, and that is how you navigate your path across that corridor or across that area or whatever domain you are in. Also, if you take legal system of any country, so if a wall thickness of 5 mm was required to retain X pressure, maybe say 30 psi or whatever, and if the designer has not taken a correct value of thickness and it is noted in a drawing, so in case of an accident, that drawing can be used in a legal system as a proof indicating that the correct work was not done. So, what is the importance of engineering drawing in your day-to-day activity apart from the BOE exam? Do you find a plant which is totally made by a single country or a company? No. Why? Because you would have automation from a country A, or you would have turbines and electrical from a company B or a country B. You would find the installation done at a different country. You would find the user base or a commissioning engineers of a different country. So, how would you integrate the forces or the resources available in a manner which is very precise, very technical in nature? So if a Chinese guy was to use his language or a German guy was to use his language of communicating, how would things integrate in a correct manner? This is where engineering drawings comes into play. Irrespective of country of origin, you would find a hidden line is a hidden line, a sectional view is a sectional view. Only difference that you would find is ideally a first angle projection and a third angle projection. Or you would find inch and feet, or you would find PSI and different forms of pressure, that is bar or kg per meter cube or centimeter cube. You would have opened a drawing of your plant or your piping system just to observe what goes where, and you would be overwhelmed with the amount of data. I hear people telling me that sir इसके अंदर 5-6 हज़ार लाइन्स है 200-300 डायमेंशंस है. I also hear sir I do not understand the drawing, I find too many things going around. You know why? Because drawing is not something which you open for the sake of opening it or view it like a drawing of art. It is not an art drawing. Art drawing is something, or a painting is something which you visualize, stare and enjoy. Engineering drawing is more like a map. Unless you don't have a query, I want to see what is the shortest path from Goa to Bombay, and then you open a map, it makes more sense. How many times have you used Google Maps without the need of navigation? Rarely, right? Same is the case of engineering drawing. So imagine a query in your mind before opening the drawing, right? So imagine you want to count the number of pumps. Create a dummy query. Even if you don't have a query, create a dummy query. Or find out what are the 6-inch line sizes available. So create any dummy query, and when you then open a drawing, it will be more useful as your attention will be more focused and more resolved towards a particular shape of geometry. So when I say a flange, you would not find something triangle in the drawing of use to you, right? So you will not find a square thing of use to you, okay? You will only find circular flanges which would have either maybe a bolted configuration, and that is where your focus attention would be. So this is how you open a drawing. What data does drawing communicate? So we can start by saying it communicates first angle projection, third angle projection, sectional view, assembly drawing. Yeah, those are forms of drawing. But what is the critical data that a drawing carries? So today I will break a myth and hopefully make you understand a drawing in much clearer form. That drawing can only communicate 3 forms of data. Drawing can only communicate 3 forms of data. First, it is what is the shape or the profile. Second, what is the size of that profile. And third, where it is positioned. So imagine me speaking 5 statements. There is a hole in the table. There is a 50 dia hole in the table. There is a 50 dia through hole in the table. There is a 50 dia through hole 50 mm from left edge, and there is a 50 dia through hole 50 mm from left edge and 80 mm from the top edge. It is only the 5th line or the 5th statement which delivers the full functional information of that hole. Engineering drawing does the same thing. So when I said hole, circle clicks into your mind. Why not square? Because the first thing that forms in your mind is a profile. Then I went ahead and explored 50 dia, or I added a data of dimension. So profile, size, and the last statement indicates 50 mm and 80 mm from both the edges. This is where the hole is located. So if you understand, drawing only dictates or makes you understand or passes on the information 3 things. उस चीज का शेप क्या है, क्या वो गोल है, क्या वो स्क्वायर है, उसका साइज कितना है, अगर गोल है तो कितना गोल है, 50 का गोल है, 100 का गोल है, और वो चीज कहाँ है, वेयर इज इट लोकेटेड. If you convey this 3 data in drawing, I feel everything is conveyed in the drawing. It is just because all these 3 data are not always visible in one particular view. शायद front view में उसका size दिख रहा है. Maybe in front view you can see the size, but not the location with respect to some geometry. Or maybe you cannot see the profile correctly in the front view. You can see it in the side view. This is where we use multiple views and sectional views and all form of drawing data or forms just to communicate 3 things. I'll just recap: profile, size and position. I hope this was insightful to you and you make best use of it. Thank you.